We're going to go and open this microwave. This is a 100 kilowatt microwave generator, and they all have similar components. So when we open this inside, we have 480 volts coming up in the US voltage, and basically some controls and some transformers, because we have to increase the voltage in order to generate the waves. So this is on the other side where we have the transformers, and then we have a set of diodes or rectifiers that gives us DC, and the magnetron that generates the microwaves is right here for safety. It has a shield on it. In order to better understand it, I have another microwave generator. We open this one and take a look at it as well. Again, it has a incoming 480 volts that comes in, a transformer that converts the 480 to 15,500 degrees, a set of rectifiers, a magnetron, a circulator that sends the waves out into a waveguide that then we can put to use. The circulator also redirects the reflected microwaves into a water load so as to prevent damage to the magnetron. Here is a complete microwave system with a 500-gallon vessel. And we're showing this because it's sitting on a 6-foot by 6-foot skid that can be shipped in a container. And we have the principle of plug and heat, because once you get 480 volts electricity, within a day, we can have this thing operational. We need a chiller to cool the magnetron. So the chiller sends the cooling water to the magnetron. This is a 100 kilowatt microwave. And because it's on, we will want to do a leakage test on it. I also wanted to show an old microwave system. The first one we started in 2010, and you can see the waveguides running all the way. In this case, the waves are going into the vessel from the top. There are some safety instruments that we use. We have a handheld microwave leak detector. We have temperature sensors that close the loop. We have a wall mount leak detector that will sense any leakage in the air or in the ambient area. We have arc detectors and magnetic switches for the microwave door that in case it's not closed, it will not let it run. If someone forklifts the waveguides and breaks the waves, the wall leak detector will sense it and will stop. And so we're going to start the machine or the microwave, so we'll do a quick check, but let me just walk through where the waves go. Here the waves comes out of the microwave. We have a load, which the circulator uses for reflected energy. The power goes into the vessel. And normally this area is covered for washdown purposes, but we have it open. So the waves go through a patented window. We have 2 windows on the vessels. In this case, we're just using one of them. So here we're going to start the microwave, and we want to run just about 10 kilowatts of microwaves. And the reason being, we want to show that when you are applying microwave power, you'd also get some reflected power. In this case, we can see on the 10 kilowatt, we're getting about 7 to 10% reflection. But we can also tune the microwave power that's going into the vessel. In this case, we have already tested this, so we know that if we wanted to tune this, we can go to 275 here. And now we're going to run this again. You can see that now the reflection is 0.4 on a 10 kilowatt. In fact, we can actually bring this to near zero with tuning, but right now for this demonstration, we have it at 0.3 to 0.4. Our vessels do not use propellers or mechanical mixers, although that's possible to do. So we've got 4 jets. These jets actually can be rotated to have the motion. We can have circular motion. We can have two jets go one direction, two jets go one direction. We can have chaos created, or we can have smooth mixing. At this time, there is no mixing going on, so we're going to turn the pump on. Right now, it's sitting on 30 hertz. We start, the VFD is 30 hertz. We start the pump, and we check the mixing. There's some gentle mixing at 30 hertz. Now we're going to go and we're going to change this now to 60 hertz, the maximum speed, and see the motion of water. So this would be a lot louder. And now we can see that we have some very strong motion of the water. And we also have a fifth jet or return line that creates a fifth entry into the vessel in case we want to get better circulation. We've run numerous tests on these, and in this case, we are at 80 degrees centigrade in the tank, and we can see the circulation lines are at about 73 degrees. These are not insulated at this time for demonstration purposes, but once they are installed in the plant, we'll have them insulated.